Number 6, use the Lagrange error formula to find the error for estimating the natural log of 1.75 by the third degree Taylor polynomial for ln x centered at x equals 1. So I'm going to go ahead and write down things that we know. We know that my x value is going to be 1.75. We know that the center is going to be 1. And we know that the degree is 3. So if you recall the formula, it is the max of f. Since we're the third degree, we will be finding the fourth derivative of x. Actually, it will be of z. Remember, I'll write that in a minute, what z needs to be between. And then times 1.75 minus the center to the fourth power all over 4 factorial. All right, so we need to say that z is going to be somewhere in between 1 and 1.75, and again, we'll just pick one of those based on when we're taking the derivatives. All right, taking the derivatives, we're talking about ln x, so f is equal to the natural log of x. I need to get out to the fourth derivative. So the first derivative is going to be 1 over x. The second derivative is going to be negative 1 over x squared. The third derivative is going to be 1 over x cubed, I believe, but let me just make this be next to the negative 2. Yes, that will be 2 over x cubed, which is 2x to the negative 3. And then the fourth derivative is going to be negative 6x to the negative 4, which is negative 6 over x to the 4, if I recall correctly. Okay, so then from here, we need to just figure out which one of these is going to give me the biggest derivative. Is the 1 going to give me a bigger derivative, or is the 1.75 going to give me the bigger derivative? And if I plug into this, remember, we're not considering the negative because we're going to be taking the absolute value. So does 6 divided by 1 to the fourth or 6 divided by 1.7 to the 5 to the fourth give me the bigger answer? 1 definitely will, so we're going to actually plug in the derivative at 1 here. So if I plug in 1 for this derivative, I'm going to get negative 6. So I'm going to get negative 6 times 1.75 minus 1 to the fourth over 4 factorial. And if I do that, I should get that my error is going to be less than or equal to 0.079. All right, the next problem, according to the Lagrange error formula, the error in estimating cosine of 0.34 using 4 terms of the Taylor series for cosine x centered at 1 is not greater than what value? So it's again asking us to find the Lagrange error. It didn't necessarily tell me the degree on this one, but if we're doing 4 terms of a Taylor series, remember the first term is always a constant, and then the second one has an x on it, and the third one has an x squared on it, and the next one has an x cubed on it. So 4 terms, 1, 2, 3, 4, would give me a degree 3. So I am going to say that my degree is 3 on this one. We do need to be careful because if I was evaluating cosine of 0, it would be a little bit different because some of these terms might cancel out, but we don't have to worry about that in this case. All right, my x value will be 0.34. My a value is my center, which is 1. And so I know that z is going to be somewhere in between 0.34 and 1. So my error formula, since we're using Lagrange, is going to be the maximum, my fourth derivative, once again, and we'll evaluate it at z, and then times 1 minus 0.34 to the fourth, all over 4 factorial again. All right, and so from here, if I take my derivatives, f is equal to the cosine of x, f prime is going to equal negative sine x, f double prime is equal to negative cosine x, f triple prime is going to equal sine x, and f quadruple is going to equal cosine x. So from here, if we are trying to think of the max, if I were to plug in the cosine of 1 in here, or if I were to plug in the cosine of 0.34 into there, the cosine of 0.34 actually gives us a bigger answer, I believe. So we're going to actually be putting in 0.34 for my cosine, and if you were not sure, you could just use your calculator since this is a calculator problem and figure out which one's going to give you the bigger answer. So from here, we will have the fourth derivative at 0.34, so we'll be plugging in 0.34 in there for that, and then we'll do 1 minus 0.34 to the fourth divided by 4 factorial. When you do that, you should get an answer that is not, e is less than or equal to 0.0075.